Okay, in this video, I'm going to show how we can rough out this cavity inside of this solid here. Okay, so the first thing I'm going to do is come over here to the Boolean operation and just change the color. I'm going to change it to a transparent just by turning down the opacity or the alpha color. And the reason I'm going to do that is because when we create toolpaths, we're going to want to look in the side here so we can make sure they look appropriate. Yeah, okay, so that's good. So let's come over here to our toolpath section. And I see that someone had attempted to, I believe they were trying to mill this out here using a 3D profile. In 3D profile, even though it's 3D, it's not sophisticated enough to rough out something like this. You might be able to cut in there a little bit, but it's not the best way to do this. So we're just going to remove it, and we're going to go to our 3D instructions and insert a rough solid. Okay, for this, the tool 40 was labeled 10 millimeter, and I've actually changed it to 6 millimeter. Okay, so it's actually a 6 millimeter tool. Let's go ahead and just change the name here. Yeah. Okay, that way we don't get confused. Okay, so that's good. So now under rough solid, we have to do a few things here. We're going to select the solid that we want to rough, which is this whole thing here. And so what this will do is it will basically slice this up into layers and then just do pockets on each one of those layers, okay? But we don't want it to work anywhere outside of this cavity, so we're going to turn on a containment chain. So just like we would select for a pocket, we're just going to click on any of these edges here, and it will select that containment chain. Okay, so you can see it's highlighted in green, which is exactly what we would see if we just wanted to pocket this area in 2D. So now it won't try to make any toolpaths outside of that containment chain. So let's go ahead and compile that and see what we get. Okay, so that looks good. Let's do a side view here. And yeah, it looks good. So we can see the toolpath is, not going outside of this boundary. We can simulate it if we want. And we can see, yeah, that looks good, right? Okay, so that looks good. So I see that there's way too big of a cleanup there. So the cleanup is set to 2.5 millimeters right now. We're going to make this say 0.5 millimeter, something like that, and then recompile and see what that gives us. That looks a lot better. Okay, and for a 6 millimeter tool, a step over 2.5 millimeters is kind of big, but we'll just go ahead and change it to 1.5 real quick, and then recompile that. Okay, so that looks good. So that's mostly it. Okay, so we also have the maximum step down. That's going to take quite a while to cut. We can probably step down quite a bit more. So we can maybe make this 5 or 7 millimeters. And we're also going to change this rest step down to 7 millimeters. I'll explain that here in a second. And so now you can see the slices are just farther apart, right? So it's going to cut a lot faster. The rest step cut is what it would basically do is if the rest step cut is smaller, say if we make this 2, it'll feed down 7 millimeters and mill out this whole area and then go back up by the rest step down amount and just kind of clean up the areas that it couldn't get to, right? So you can experiment with that. This does not work perfectly in every case, so I'd be a little bit careful with rest step down, okay? But it can definitely save a lot of time in some cases. So one other thing that I would probably recommend is we have a side amount to leave and a bottom amount to leave. Probably want to set those to something so that you can go in there with the finish tool and clean this up without having any artifacts of the roughing operation. So something like, I don't know, maybe 0.5, maybe 0.25, I don't know, something like that. And then we'll just go in there and clean it up with the finish operation. And that changes it ever so slightly. It's not going to do much there. Okay, so that looks good. So let's go ahead and do a finish cut real quick on that. I'll just comment this out, comment both of those out actually. And then we'll insert a parallel finish cut. And for this, we're going to, I don't really have a good metric tool set up here, so we're just going to use a 1/4 inch ball end mill. Okay, so for this, we're going to, similar to rough solid, we'll select the whole solid here, And we probably don't need a containment chain because we're just going to select the faces that we want to work on, that we want to finish cut. So we can just select them individually like this, or another quick way to do it if you have a lot of faces is you can click on one and then drag over, and it will select anything that we drag while the mouse is down. Okay, so that's good. So we have 5 faces selected. Let's just see what that gives us. Okay, so we've got a really fine step over here. We probably don't need that, and I think we're kind of going the wrong way. We probably want to cut this the other way. So let's change the XY angle. So that kind of, if you look at the XY angle of 0 degrees is going to cut in the 3 o'clock direction. So we just want to do the XY angle of 90 degrees. And then our step over is way too small. Let's just go ahead and make it 2 millimeters for now and compile that. Okay, so that looks good. Okay, so let's go ahead and simulate that. Okay, so it's kind of, that's going to be big. So these cuts up at the top, they're just kind of rolling over the edge there. Then this first cut, you really want to make sure you have everything roughed out before that cut, because that's going to be a big cut. So, yep. Okay, that looks good. So that's really most of the options that we would want to change here. You can see that this overcut option here, I'm not sure if we turn this overcut option to false, if that's really going to change much of anything. It doesn't really look like it changes much. But in a lot of cases, you don't want it to roll over. This is not really rolling over much because we have this face here, so it knows that it can't. So yes, that's pretty much what we get there. Okay, so I guess that ought to do it. Okay.